Hello, everyone. Welcome to our event. This event is brought to you by DataTalks.Club, which is a community of people who love data. We have weekly events, and this event is one of such events. So if you want to find out more about the events we have, there is a link in the description. Go there, click on this, and you'll see all the events we have in our schedule. Then if you haven't subscribed to our channel, do this. There is a big subscribe button below this video. Click on this and you'll get videos from us in your YouTube feed. And then finally join our Slack community, and yeah, you'll like it. We can talk about all different data topics there. And during today's conversation, you can ask any question you want. There is a link in the live chat. It's pinned. So just go there, click on this link. You'll go to Slido and you can ask any question you want there. So yeah, that's the introduction. Okay. This week, we'll talk about similarities and differences between machine learning and analytics. And we have a special guest today, Rishabh. So Rishabh has worked with analytics and machine learning teams for more than 7 years. Most recently, he led a sales engineering team at a data infrastructure company called DataCoral, which was acquired by Cloudera, and he was helping analytic teams with their data pipelines there. Before that, he was one of the employees at Primer AI,
Primer.ai.
Yeah, where he built and deployed machine learning models for multiple natural language applications. So he also writes a newsletter called MLOpsRoundup that discusses challenges with machine learning in production. So subscribe to that. It's MLOpsRoundup.substack.com, right? So this is a cool newsletter. I am subscribed, so you should also do. And yeah, so welcome, Rishabh.
Thank you. Thank you for having me, Alexei.
So before we go into our main topic, let's start with your background. Can you tell us about your career journey so far?
Yeah, absolutely. I mean, I think you covered a little bit of that, but I'll give you a quick introduction myself. So, until recently, I was at this data infrastructure company called DataCore, which we'd just been acquired by Cloudera. But sort of, in my time there, I had worked on engineering, some product work, and then some sales engineering work. And really the goal for the team was, how do you sort of help data scientists move data from point A to point B as efficiently as possible, right? So that they're not blocked on data engineering resource. So we had like a nice little product that would allow them to do that. And before that, I was doing sort of machine learning work myself at a company called Primer. And there, we were basically helping customers make sense of a large amount of unstructured text. So a lot of fun kind of NLP problems, including summarization, sort of entity extraction, sentiment, classification, all of those fun things. So that was kind of my journey at Primer. And before that, I was at Stanford doing a master's in computer science. So lots of machine learning classes there, but I was also a TA for a few classes, including the Andrewing machine learning class. And as you mentioned at the end, I write this newsletter called the MLOpsRoundup. Yeah, it's been a pretty fun journey this past year to research, think about what is interesting to the community, and just kind of write my learnings there.
Yeah, cool. I'm really curious, what did you do as sales engineer? So maybe in a few, I know it's a bit of topic, but I'm really curious, what did you actually do there?
Absolutely. So, it's still a very technical role. I mean, it's about kind of helping folks who are evaluating the product, best understand what are the capabilities, what are the sorts of problems that it can solve for them. And basically what are the things that it can do, what are the things it can't do. So a lot of my kind of work was actually just working with prospective customers, either doing demos, sometimes running trials with them, and sometimes just kind of getting in the weeds with kind of their data infrastructure and saying, okay, maybe you might want to change, this little thing X here, because, not only will this integration with us become easier, but also it'll make your life easier down the line. So it was a lot of just, getting into the weeds with, data infrastructure stuff for our customers, and then taking, the product that we had and saying, here's how it could help. Here's what it could do for you.
Mm-hmm. So, which I guess also involved doing some proof of concepts.
Absolutely. Yeah.
Then the customer would evaluate if this POC works for them or not. right?
Exactly. So I was responsible for sort of the trials that we used to do with companies and the POCs. Yeah.
Mm-hmm. Yeah,
Yeah.
interesting. Yeah, so
Yeah.
you mentioned that you did masters at Stanford and you were ATA at Andrew Ng course.
Yeah.
That's cool. So I took that at Coursera. Not,
Yeah.
of course, I think it's pretty different from the real one, right?
Yeah. Yeah, I
Okay.
think it's funny because I think some of the problem sets and such might be similar, or like the programming assignments at least. But
Mhm.
I haven't seen the exact courses, but yeah,
Okay.
it's still pretty good. Yeah.
So I was also doing masters, although so I wasn't really studying computer science. I think I ended up getting a master's in computer science, but the main direction there was BI, business intelligence. So I was studying BI, and yeah, so we were taking courses like data mining, data warehousing, business intelligence, all these kind of things. And we there in our courses, we studied two types of analytics. So one analytics was prescriptive analytics, and the other kind of analytics was predictive analytics.
Mm.
And sometimes for this predictive analytics, we would call it data mining, right?
Mm.
So it's not like you not just dig something up in your data, but you also
Yeah.
do some prediction there, right? And so I guess this predictive analytics, this is what today we call machine learning to some extent, right? So this is what we analyze some data that we have
Yeah.
and do analytics for doing predictions. But still, there is a reason why this thing is called or was called predictive analytics. So do you know what is the main difference between these two types of analytics, prescriptive analytics and predictive analytics?
Yeah. This is super interesting because like many different fields have been working with data in different capacities for decades at this point, right? So today we're kind of having a conversation about analytics and machine learning, and it's very much kind of the modern context, right? Like today's context. And even sort of you reference the word kind of data mining, right? I mean, data mining is kind of this old school kind of term, but it's really about just extracting patterns from data, and you can do some extracting patterns by sort of some machine learning techniques. Sometimes you can do it by sort of clustering and sort of those unsupervised kind of techniques. But then there's also kind of classic kind of data mining techniques. And I'd be curious about sort of the predictive versus prescriptive, because predictive definitely sounds, and from my kind of very minimal understanding, it feels very similar to kind of machine learning work. But prescriptive, from what I gather at least, it's like it kind of goes above and beyond. It's also how do you explain this decision that was made? What are the implications of a particular decision that was made from a prediction? And so it kind of encompasses a little bit more. But is that generally how you remember kind of prescriptive analytics?
Yeah, exactly. So, like, if I translate what I studied to
Yeah.
the work I'm doing now, to the work we are doing at OLX Group, where I work, so I would say that prescriptive analytics, this is what data analysts do, and
Mm.
predictive analytics is more what data scientists do.
Yeah.
But like in addition to building services, so there
Yeah.
at university we were focusing more on algorithms, but not on the actually putting this thing in production, of
Yeah.
course. Uh,
Yeah.
but yeah, I think this is from what I remember, this was the main difference. So prescriptive
Yeah.
is going through the data and understanding what is there and then coming up
Yeah.
with a report. And this is what I see analysts doing, my colleagues analysts are doing, coming up with reports or dashboards. And predictive analytics is coming up with a model. And then again, in BI, this model would, continue, let's say, do some predictions for time series, and then you would
Yeah.
put this on the dashboard. So things like this.
Yeah,
But
that
still, you
makes
have
that makes a lot
this.
of sense. Yeah. And it's funny, right? Like, I mean, I can totally imagine 5 years from now, right? If we have this conversation again, I bet the names would have changed a little bit, right? And we'd be talking about a slightly different concept, but it feels kind of similar to what we've seen before. And I think that's just how it goes.
Yeah, and actually, in the question that I put initially there, I wrote data science, and then you left a comment saying, "Hey, let's not use the science here because it's too ambiguous, right? It can mean too
It's
many
too
things."
overloaded. Yeah. I mean, it's at least to me, right? Like data science at different companies, like it can end up being just vastly different jobs, right? And sometimes, I mean, honestly, like if somebody were interviewing for a data science role, I think it's pretty important to just ask the team, right, exactly what they mean, exactly the kinds of projects that they can imagine that the person will be doing, because it can mean everything from sort of you write some SQL and then you write some code to you build like these machine learning models, and so everything in that space.
Yeah, because you mentioned that it's interesting how this would be different in 5 years, and it's also curious to me how data science will be different in like in 5 years, right? In 5 years.
And I mean, we're seeing some of those changes already, right? I think I saw you interviewed somebody around analytics engineering. Is that right?
Yeah,
And
exactly.
that's a very recent thing, right? It's only maybe gained steam in the last kind of 6 months to a year, right? So we're already seeing kind of a new thing emerge that probably is here to stay.
Yeah, definitely. Then yeah, who knows what happens with data scientists? Yeah. So can we actually say that, so we talked about this predictive analytics and prescriptive analytics. Can we say that machine learning is actually a part of analytics, or they're two different things?
Yeah, I mean, I would. So, maybe kind of, putting the sort of predictive versus prescriptive kind of aside, because there might be some connotations of, being a subset there. I mean, to me, sort of analytics and machine learning, they feel like kind of distinct. I mean, the goals there are slightly different, right? So maybe this is a good time to kind of go into some sort of them in a little bit more detail. To me, sort of analytics is about looking at data in the past, right? So it's about looking at history and trying to understand what happened, right? So that you can answer certain questions. I mean, the data is there, right? So there's a true answer that you're looking for, assuming that you've collected the data, but it's about, here's what happened. Whereas machine learning work is often about sort of looking at data in the past, but can you predict stuff in the future, right? It's always kind of forward looking. It's about making predictions, making forecasts, and there's no kind of guarantees that you're going to get it right. It's about coming up with the best guess, right? So at least viewed from that lens, like they end up kind of being kind of different things. Although sort of they might have shared sort of data infrastructure, they might have the same people working on them, but often the mentality and sort of the sort of outcome of these two ends up being a little bit different. So yeah, coming back to your original question, I mean, maybe some people would classify sort of machine learning as part of analytics, and maybe that's because often machine learning work begins in sort of like the classic kind of analyst teams, where they're like, maybe here's a place where we could train a machine learning model. So maybe that's how it emerges at a few companies, but to me, they feel very different.
Yeah, I saw in a couple of talks about data engineering. So data engineers, at least in those talks that I saw, they refer to machine learning things as analytical workloads, like analytical stuff. So they're like these things like training a model or scoring customers, they would refer to this as analytical workloads. Because I guess from data engineering point of view, it's kind of similar. So you're going through the data, you're doing something with the data, and then you're producing more data, right? So from this point of view, maybe it's not that different.
Yeah, that's possible. Look, I'll probably caveat this with the fact that because I've been sort of in the field, so to me, maybe similar things also feel different, right? Whereas maybe somebody looking at it from a little bit of an outside, like it's just kind of the same thing. But yeah, I totally hear that. Yeah.
Yeah. So basically, analytics is looking in the history and then describing what happened there, and machine learning is more forward-looking, describing what will happen. Okay.
Yeah.
And so for analytics, usually it's data analysts working on this, right? And for machine learning, we can argue whether it's data scientists or somebody else doing machine learning, right? But let's say it's data scientists, right? So what kind of work they do, people who work with machine learning, like what does the day-to-day work look like?
Yeah. So kind of the starting point for that is, what is the outcome, right? What is the thing that a data sort of science team, machine learning team is producing, right? And typically it's going to be sort of either a live running system, which basically you submit kind of questions to it and it returns with the prediction, right? So something that is like a machine learning model behind like an API, right? So that's like a system, live system that they're producing. Or they might be producing sort of predictions that are computed on a daily basis and then stored into a database, right? Such that they can be consumed by, let's say, the product later on, right? So if you think about it, it's a live system that they're producing, and there are sort of predictions to be made. You can imagine that some of the work that they're doing is figuring out how do we make sort of the prediction quality better, right? And that involves like a whole set of kind of machine learning activities, right? Gathering data, labeling data, training models, hyperparameter tuning, and then you get into some of the more system aspects, which is how do you actually deploy it, right? What are the SLAs that maybe the live system needs to produce, right? So maybe many companies kind of have fraud teams, right? Like that are trying to detect fraud, and some initially they start out as kind of rules-based activities, but eventually they kind of transition into doing some machine learning. And then with fraud, you kind of have to catch that reasonably early, right? For example, if you're onboarding somebody and you wait like a few days, that might already be too late. So it's about, so they often have to think a lot about kind of these SLAs for the system. So it's again, coming back to sort of the original question, it's I think like machine learning folks like often spend a bunch of machine learning engineers, at least, like often spend a bunch of the time, how do we improve quality of the predictions when we're training the model, but also on an ongoing basis, and then sort of how do we improve the system such that it actually is performant from a software perspective. Has that been your experience as well?
Yeah, and interesting that you mentioned that machine learning often started in companies in these fraud teams. They first started with rule-based systems and then added machine learning. So this is actually, to my knowledge, this is what also happened at OLX Group. So it was before I joined, but as far as I know, so this is the first big use case of machine learning at OLX Group. It was like 5 years ago, or maybe now 7 years ago. Like it was way back, like before I joined. So this is really interesting that you mentioned. And yeah, the experience from what I saw, it's very similar that there is this system aspect, or I would call it maybe engineering aspect, that it's not enough just to create a model, I don't know, logistic regression, scikit-learn. You also need to take care of other things. And this is what data scientists do, or you can call them machine learning engineers. But this is what needs to happen to be to be able to use the model.
Yeah. And maybe, I mean, I know we're going a little kind of off script here, but the rules-based system into machine learning is always kind of fascinating because I think a lot of sophisticated machine learning fraud detection teams also still continue to use a lot of rules. And I mean, the simple reason is like rules are really fast, right? Somebody can just like see some data, write a rule, and have that deployed in like 1 hour, compared to training a machine learning model with maybe that as a feature, or maybe like a separate model which can take on the order of weeks. So it's about like kind of the speed that you get. And I was recently talking to sort of a team that does kind of fraud detection, and so they'll have like a team that is kind of coming up with these rules and kind of getting these deployed, and then eventually if a rule is kind of important enough, it'll become like a feature in a model, or sort of become its own model at some point, whereas some rules will kind of die away because those patterns don't work anymore, and it's kind of this constant kind of battle that is going on.
Exactly, and these rules, at least what we have at OLX is we have like a UI where fraud specialists can just go there, click a button, and then they have a rule, and then they can see how effective this rule is. And all these things with machine learning, it would take a few more iterations to actually do this. And yes, speaking of that, so like we just talked about the rule, and then we see how effective it is, all these, charts. So I guess this is something that maybe analysts would do, like doing some sort of analytics. Let's say we have a rule, and then going there and understanding how this rule, how it is effective, right? And what is the, I don't know, like false positive rate and things like this. Is it something that analysts would do, right?
Absolutely. I mean, I think, for example, like you might have either, sometimes it can be an analyst, sometimes it might be sort of a fraud specialist, as you said, right? Or an operations person who might define the rule, right? Because it was relevant in that kind of given moment. But then it might actually be sort of like an analytics team or analyst who actually looks at sort of, performance of that rule, on an ongoing basis, right? Like which rules actually continue to work, which rules actually flagged important stuff. And then as they gather, sort of the true labels, right? Whether a particular transaction or particular user was fraudulent or not, like, yeah, then they'll be sort of comparing this and saying, these last 20 rules are not working anymore. Maybe we should get rid of them. Or, they might actually even kind of look at sort of once they have that true data, right, which were fraudulent or not, they might actually have a good sense of, here are the kinds of examples that were still not caught, right? And so they might be providing those recommendations, guidance. But yeah, absolutely, this would be some of the work that an analytics team might do.
So this term prescriptive analytics. An analyst, a team of analysts would do analysis. They would analyze all the rules, and then they say, okay, these 20 rules are not working anymore, and then they kind of prescribe. They say, okay, throw these rules away; they're useless, right? So this would be a prescription. That's why it's like they have some sort of report at the end, some sort of recommendation, some sort of decision. Okay, we analyze the data. This is what you should do based on our analysis. Like, would you say this is the main outcome of the analytical work?
It's definitely one of them. I mean, I think if I were to look at a few different things that like an analyst would be expected to do, right? There are some things that are, like ad hoc queries, right? That they'll be asked to do because, their boss or their boss's boss will say, hey, I need the answer to this question, right? And I need this because I'm presenting to person X or team X, and this needs to be in my slides, right? So the person, the analyst will probably go to their kind of favorite SQL client, write some queries and get that answer, right? So that's probably like, I mean, depending on the sort of teams, that can often be, close to 100% of the work, although probably shouldn't be 100%. So that's kind of one aspect of like their work,
like,
right?
The second of fraud example, this request could be like, hey, what are the I don't know, success ratio for these rules was the last month, right? Because we have a board meeting and we want to show how our team is effective, right? How effective it is. So please prepare this. I need it as
absolutely. Right? Yeah, I mean, they could be answering sort of all sorts of questions like, how many kind of, fraudulent cases were found, how many were caught in time, right? What was the sort of overall damage, or whatever the right word is, that was caused by kind of the fraudulent activities. There's so many kind of interesting questions there, right? So it's like part of their work is this. Part of that is, I think you were referencing sort of coming up with these reports and recommendations, which is absolutely a super important piece of work, right? For example, if a data science or data analyst person is kind of embedded in a product team, right, then often they're working closely with the product manager to say, if we build this feature, right, it's probably going to kind of impact, this kind of user. This is maybe how we can kind of model the sort of improvements or maybe a particular hit on some business metric if this gets released to kind of 100% of traffic versus maybe if it was only released to 2%. So there's all kinds of questions there, right, that they might be helping product teams with. And then there's a whole set of activities that sort of a data analyst might be doing when it comes to, let's say, integrating different sort of data sets, right? So they might already be working with certain data sets in their sort of database, but then, let's say they find like an API, right, for a completely different new data set, which has some signal for them, right? So they might probably spend some time exploring the data, seeing what that can bring when joined with their existing data. So there's a bunch of activities there. And of course, like, one of the kind of maybe unsaid parts of a lot of this data work is, often a lot of education needs to kind of go into it, right? So, whether it's data analysts, data scientists, or data leaders often, right? Like they spend a lot of time, telling people this is actually what you can achieve. This is what you can't achieve with the kinds of things that we're doing. And here's maybe the question that you should be asking before you make important decisions, right? There's a lot of kind of important work that goes on there.
Yeah, and in my experience, I see that analysts help a lot with, let's say there is a new potential project that, let's say we think that machine learning will help. And so what analysts often help with is understanding the size of the problem.
Right.
and then seeing, okay, like maybe actually just 10 users complained about this.
Yeah.
Yeah, maybe it's not actually worth solving it, or like maybe
Yeah.
let's give it a lower priority, because there is this thing where 10,000 user complained, or I don't know, a lot of
Yeah.
users, versus this one, like it seems to affect fewer users. And then the other thing I noticed is, I'm a data scientist myself, and I noticed that data analysts know data a lot better than me. So they know
Mm.
where things are. So if I need to find something, usually I use this hack. I would just go to an analyst and say, hey, I need to find this data. Can you help
Yeah.
me? And then they would,
Yeah.
here you go. This is a SQL query.
Yeah.
You can just go with this. And yeah, it saves a lot of time. So I think data
Yeah.
analysts
For
know
sure.
data a lot better than than me for sure, but maybe for better than an average data scientist as well.
Yeah.
Because I imagine they spent the entire day crunching this data, like
Yep.
doing all these queries and then doing
Yeah.
reports. So
I
they,
mean, that's exactly it, right? That's where they spend a bulk of their time, and so they are the expert, right? And often, I think a lot of data analytics work is, tying sort of what data we have to important kind of business metrics. So they have like a very kind of at least senior folks who've kind of spent time with their data. They have like a very keen sense of what to look for, what are common gotchas, right? Like what are things that commonly go wrong, right? Like there might be kind of classic things where oh, to make this query work and get you the right data, you have to add this where clause, right? If you don't write this where clause, then you'll get a bunch of kind of garbage data, right? And often like that kind of knowledge is kind of with
tribal
specific
knowledge,
people.
right?
Yeah. Yeah.
Yeah, exactly. So even if it's documented, maybe it's
Yeah.
in wiki somewhere where nobody, nobody
Yeah.
looks at, but these people, they know, and they would just say, hey, your
Yeah.
query is wrong. So here's the good one. Yeah.
There are folks building kind of good tools for sort of this documentation, but honestly, I've kind of yet to see like documentation systems for this that really work, and I hope we get there, because otherwise it's kind of hard to scale.
Mhm. So was it something
Actually,
that you?
I had a quick question
Yeah.
around like you mentioned at OLX sometimes like analysts would kind of help answer questions of like it only affects 10 people.
Mhm.
Do you find like analysts are kind of often brought in at the right time to be able to answer those questions, or how often are their recommendations heeded?
Yeah. So we use like the setup is we are embedding data scientists and data
Mm,
analysts in teams. So
yeah.
yes, usually it happens at the right time.
Nice. Nice.
Hopefully, most of it.
Yeah.
Like sometimes
Cool.
it didn't happen, and then we ended up spending time on something we shouldn't have. But I guess it
Yeah.
happens to everyone, right?
Yeah.
So
No,
sometimes.
that's awesome, honestly, because
uh,
I think there's plenty of kind of stories of like a product manager saying, hey, this is the coolest feature that needs to be built. And often you can write a simple query to say that this will only affect like, a
mhm.
small number of people, maybe not worth it. And it doesn't happen in time, but that's awesome to hear.
Yeah, we actually call our data analysts not data analysts but product analysts. So they work very
Mm,
closely with product managers, and
yeah.
so they are more a lot they're quite into the product work, so they are
Hmm.
very product oriented, I would say.
Yeah.
So it definitely helps that they're close to the product, and they know what is important for users and what is not important for users. They know it a lot better than data scientists, I think.
Hmm.
So I think data scientists need to learn a lot from product analysts when it
Yeah.
comes to
Yeah.
that, to understanding what is important for the product. But it's good that we work together, so we can always learn from each
That's
other.
awesome.
And when I think about this, I think that data science work or machine learning work is more experimental than analytics. So in data science, you have a hypothesis, right? You have a hypothesis that you want to test, and you build some model or something simple, and then you test this hypothesis. While in analytics, at least I might be wrong because I never worked as an analyst myself, but I think it's less experimental, right? So it's more clear what they need to do because there is some ad hoc query or some report they need to do. Do you think this is a correct observation?
Yeah, I think that's definitely fair. I mean, one of the things is that both types of work are fairly iterative, right? So You have to kind of try something, see if it works, try something slightly different, see if it works. So in the world of kind of analysts, right, like they're often kind of iterating on kind of different kind of versions of SQL, right? Like I know kind of analysts who have like thousands of lines long SQL queries, right? And they're kind of making small changes as they understand, something new about the business. They want to add something slightly different to the query. So there's often like this iterative work, but it is still kind of in the service of finding something that is kind of true, right? Like an answer that is true based on sort of the history of the business and the data that's been collected. Whereas with sort of machine learning work, you're right, it is kind of fairly experimental, and sort of the iterations themselves are the experiments, right? So you might have experiments that are running sort of pre-deployment, where you're just testing out a bunch of different models, you're testing out different features, you're testing out different hyperparameters. So there's a bunch of experiments going on there. And then there are sort of, depending on sort of the scale of the company and their sort of infrastructure setup, you might be doing sort of experiments on live traffic, right? Before kind of releasing the full model to prod, you might be running them in shadow mode, or you might be sort of doing kind of these A/B tests with model. And so definitely it feels very experimental. I mean, a lot of machine learning is just kind of empirical results on kind of the data that you're seeing and observing, right? There's no kind of who knows what the right perfect model is. It's just this is working best, right? And that's the guiding principle. So yeah, I think that sort of data science and machine learning work being experimental makes sense.
And from what I see, again, not only at OLX, but also in other companies, that so we talked about this experiments on live traffic. Usually it's A/B tests, or can be shadow testing.
Yeah.
So this analysis of A/B tests or whatever live experiments is often also done by analysts, right? Or together with data scientists. So it's data scientists or machine learning engineers and machine learning engineers work together, let's say, on setting up experiment, having two versions of model, like baseline model and new model improved.
Yeah.
And then together with analysts, they analyze the results and see, okay, let's say we have an uplift here, but why this uplift happens? Like, is there any specific segment of users where this uplift happened, or an uplift across all the cohorts, all the segments? So this is something that analysts would do. So they would dig in, or especially when experiments go wrong, when they are not successful, like why it happened, why a new model that was perfect in offline experiments resulted in not uplift, but even like the performance was worse than the baseline. Like, why did it happen? And then maybe there is one specific category where it was bad, and in other categories it was good. And this is something that often analysts do, or help a lot with doing this kind of work.
Yeah, I mean, I can totally see that. And, we were talking about this earlier as well, right? Often, like, you'll have analysts who are much closer to sort of the business metrics, right? And their understanding of kind of, what is actually improving the top line or sort of improving the bottom line in whatever respect, right? And having somebody who, is helping the machine learning team kind of keep very close tabs on, is it actually moving the needle or not? Right. That is pretty important. And, I think like, there are some machine learning teams where, they have that sort of mentality and they have that sort of expertise built in. But if not, right, sort of the model that you're talking about, I mean, that's perfect. That's exactly it.
Yeah. So maybe we can summarize a bit. So what, in your opinion, are overlaps? What are the similarities between machine learning and analytics?
Yeah. So, I mean, in terms of similarities, I mean, it's the data is the biggest one, right? Like these are both kind of two professions which heavily rely on. I mean, without data, nothing works, and without good data quality, nothing works. And whenever it comes to data, you're kind of dealing with problems of, how do you store it efficiently? How do you process it efficiently? How do you know where this data is coming from? And how do you make sure that sort of data quality errors are kind of caught as early as possible? So you have all of these data similarities. I think we talked about sort of them being both iterative, right? Like you just have to kind of, nothing is ever quite done, right? Not even a SQL is ever quite perfect, because there's probably something that is missing, and models for sure, right? Like models break all the time, and you need to kind of keep updating them. And one of the other, I mean, things is that at least today, like often it feels like the same people are kind of working on both analytics stuff and sort of machine learning stuff. I think there are teams where sort of this kind of or at least within teams, you'll have specialization where somebody kind of does, a bulk of like just working with SQL, and somebody does kind of more of the machine learning and modeling stuff. But it still feels that like there's, there can be a lot of interchange there. And of course, when compared to kind of software, right, they're both fairly less mature, right, as ecosystems and sort of processes and how to actually do stuff. So there's a lot there's a lot that will change, and there's a lot of change that is going on already, but there's a lot that will change about how this work gets done. So I think in my head, at least, those are roughly the similarities, and then sort of differences, right? Like, I mean, it's to me, some of the differences come from like what are the use cases that they address, right? So analytics is typically kind of helping the business understand what actually happened, what worked, what didn't work. So the use cases are often very internal facing, right? It's for the team themselves, like the organization themselves. Whereas for machine learning, often since they're like there can be internal facing stuff, right? Like forecasting, right? What revenues do we forecast? But a lot of it is actually like making predictions on kind of like for users, right? Like things that actually directly will impact users. Things like we were talking about fraud, right? Like who to kind of whose transactions to block, right? What users to kind of stop in some capacity. So there'll be a lot of external facing kind of stuff there. I think we talked about differences around what are the outputs of these two data streams. So with analytics, you have things like dashboards, reports, whereas with machine learning stuff, you have systems that are the output, right? So it's a live system that you have to kind of keep running. And again, with systems, right, like you often see that they can be fairly real time, right? So you're talking about sort of SLAs of like, return in like 200 milliseconds, return a prediction in 200 milliseconds. Whereas if you think about like analytics stuff, right, there people are comparing week on week, right? Like how are business metrics changing, which is like a completely different time scale to be thinking about problems on. And of course, there are sort of different technologies, different tools, the ecosystem, there's like slight differences there. So, but anyway, that's I can probably go on for longer, but those are some of the key similarities, differences in my mind.
Yeah, I'm looking at my notes and I don't think you missed anything. Yeah, apart from maybe like the analysts, I think maybe data a bit more, like a bit better than data scientists, because they tend to spend a lot more time with that. And you said because of the output is in case of analysts, dashboards and reports, which involves a lot of SQL, a lot of data understanding, while for data scientists, they spend more time on systems rather than analyzing data.
Yeah. I mean, maybe like even to maybe contradict myself a little bit on this. I mean, I do think that some of the best data scientists like have a very keen understanding of the business, right? Because without that, sometimes you'll just make bad decisions about what to prioritize and what not to prioritize. So, the best kind of data scientists, in my opinion, like very closely understand, why they're working on something and how that'll impact kind of, the key metrics for the team and the company. But as a rough guiding stick, I think you're right that I think like analysts who spend a lot of time in SQL working with business metrics directly, like often they kind of have a much closer sense of it.
Maybe the same is true for analysts. So analysts who spend not just time in SQL, but also spend some time programming and doing a bit of, I don't know if actually analysts do this, like the system aspects, but definitely, doing a bit of programming, doing some, I don't know, Python and things like this. Yeah, I think these probably are also great analysts, right? So those who, well, like for data scientists, for machine learning engineers who go and check, go outside of the typical day-to-day work and, do some business analytics, right? What is good for business, maybe for analysts who do and check data science and then how to do this whole machine learning stuff there. Also very beneficial for them, right?
No, absolutely. And I mean, I think it comes down to using the right tool, right? So if the existing tool, let's say SQL, right, doesn't kind of get you the answers that you need, and maybe you need to, run some analyses with pandas, right, with in a Jupyter notebook or something. I mean, then it's amazing if the sort of analysts themselves can just spin that up and write whatever code they need to. I do believe that like until recently, maybe, I mean, it probably wasn't the easiest right, to set up like virtual environments and Jupyter notebooks for people who are less familiar. And we're seeing sort of like a move into notebooks that are much more inclusive, right, which allow you to kind of write SQL and then Python sort of in the same environment, and a lot of things are taken care of for you. So I think as more and more of that happens, right, it'll become easier and easier for the story that you told of like a data analyst who does mostly SQL, writes a little bit of code, for that to become easier.
Now you are talking about this. Remember this? Not Jupyter notebooks, but the other sort of notebooks. I think Zeppelin notebooks.
Yeah.
I think I don't know. I don't think it got much traction, but the idea there was that you can write SQL query in one cell, and then you can write some Spark code in the second cell, and then in the third you can write some Pandas code, and then create these nice reports immediately in your dashboard. So that was
I personally never used Zeppelin. I mean, to me, Zeppelin was always like, if you're kind of working with the Hadoop ecosystem, it's probably like a better thing. I mean, I guess I know a few people who use it, but I mean, I probably won't name names, but like there are a couple of BI tools today that, for example, in the same kind of interface will allow you to switch between sort of a notebook experience and sort of a SQL client. There's a couple of smaller companies that make SQL and Python running in similar cells possible, and they're seeing some amount of traction. So maybe the time wasn't quite right when kind of Zeppelin came out 5-6 years ago or something. And maybe the time is right now, but who knows?
Yeah. So, right. So we already have some questions. So
awesome.
For question is, do you see overinvestment in organizations? Organizations invest more in machine learning and underinvest in analytics.
Yeah, that's interesting. I don't know if I have a clear answer to that. I mean, probably at the highest level, I would imagine that there is generally underinvestment in sort of data teams. I mean, just in terms of kind of the value that like a couple of like good sort of data people who have kind of the right infrastructure and setup, like the value that they can bring is often very outsized compared to the sort of resources that are spent on them. Between sort of machine learning and data analytics, it's possible. I mean, look, sometimes like folks who are sort of in executive kind of positions who are kind of making these decisions, like often they're kind of relying on external factors, right? So you might kind of read this piece from McKinsey or whatever, right? Like without kind of going into details there, and it's like, look, machine learning is like the kind of the hot thing right now, right? And we should kind of have like a team. We should have like be doing this. So I could totally see that happening, but it's hard for me to say that kind of without numbers. But I mean, generally, I think like more investment in this stuff is probably better. But as long as kind of we also start from investing in sort of analytics and sort of machine learning, like there's often like a core investment in data infrastructure that often also needs to be made along the side, and I think that's often like the most kind of underappreciated and underserved part of it. But
yeah, so the question continues. So it's more like a comment. I see a lot of organizations hiring lots of data scientists while forgetting about data analysts and forgetting to upskill others. So perhaps, the data science looks more sexy, perhaps. Like, people talk about machine learning, robots, I don't know, like it's cooler, right? And, dashboards and, okay, like let's hire a bunch of data scientists, put them in a room and let them magic.
Unfortunately, that sounds very true, right? Like it's data science. I mean, that's kind of why like I typically want to kind of stay away from like the term data science as much as possible, just because it becomes so broad, where using that phrase you can convince like how like sexy like a particular job can be, right? But maybe the person actually gets into that organization and they realize that there's no kind of amazing machine learning model that they get to train, right? There's just like these more kind of important pressing business problems that can be answered with SQL and just like getting your data into a better shape, right? That just that's what the business needs at that moment, right? So you often like you'll have some amount of dissatisfaction, right, for people who are hired in. But yeah, I guess it's kind of an unfortunate I would imagine transitionary period, sort of in our life, right? So maybe 5-7 years from now, things will be a little bit better defined. These roles will be a little bit clearer, and hopefully, sort of the importance and sort of the value that analysts kind of bring to the table, right? Hopefully that will sort of also be sort of reasonably clear, right? And it's not that data scientists are here and data analysts are here, because that's just not true.
Yeah, that's definitely not true. And from what I see, it's actually, and I talked to some people who are hiring both data scientists and data analysts. And one of the comments that was a bit surprising for me, but then I thought in that retrospect, it probably makes sense. So they told me that it's a lot more difficult to find a senior analyst than a senior data scientist. Have you seen this, and do you have any ideas why it might be the case?
Yeah, not 100% sure. I mean, if I were to make a guess for why that could happen, it's likely because maybe data analysts kind of like senior data analysts, or who spend that some time doing that, right? Like if they find sort of like a differential in the amount of money that they can make, right, by just moving to sort of a data science role, right? I mean, that seems like a no-brainer, right? And they should be doing that. I mean, it's also possible that I've seen like some data analysts actually make the transition from just kind of writing kind of SQL and understanding the company's data to becoming much more like almost infrastructure people, right? Because they understand what it takes to sort of have successful and kind of high performing analyst teams. So like, and maybe like this analytics engineer kind of is a trend in that direction, right? Where they're less about kind of writing more SQL queries and answering more direct questions from business, but more about structuring and setting up the data sets in a way where it's kind of, it makes it easier downstream, right? So there's probably sort of like moves that sort of analysts would make, either in the direction of data science, or sort of a little bit more upstream when it comes to infrastructure. But hiring, I think, generally is pretty hard right now for a lot of folks. But I can imagine that analysts might be a little bit harder than normal.
I also noticed that some analysts, they many go to the data science path, many switch careers from data analytics to data science, but also many go to product. So they become product managers. Not many, but I saw multiple. So because data scientists are quite close to product, so they realize that they like this product management work, and then they become product managers.
That's super interesting. Yeah.
So maybe by the time they, well, let's say they are not senior analysts, and now they see, okay, there's this data science or this product management work, and they just switch, and not so many people get to the senior position. I don't know. Yeah,
I hope that changes. If that's true, I hope that changes. Yeah.
So maybe because, as you said, maybe it does look like in industry, data science looks more sexy, right? Because there's certainly more hype around this than analytics. Because analytics has been around, I don't know, 3-4 decades, right? While data science is something more fresh.
Yeah.
At least in when it comes to, we had this data mining, of course, which is very old, but
yeah, it's kind of funny. I think I don't remember where I was reading this, but sort of even the terms of kind of data mining, like they're not very popular when they started, because there was something kind of, I mean, people felt a bit icky about the fact that like you're having to rely on sort of empirical data to come up with like right decisions, right? And you don't fully understand the problem deeply, right? Like from your heart, right? So like the practice of kind of digging into actual data to figure out like, what is correct and what is right, like it was kind of frowned upon, I think, when it began. But it's kind of funny that like today, like everything kind of seems to run on data and everybody's all about data.
Yeah. Thanks. So we have another question. So should our team work independently or together? So let's assume we have a machine learning team and analytics team in our company. So should we put them in one room, or should we put them in separate rooms?
That's a really interesting question. So maybe I'll caveat this with, look, my sort of experience with this is limited, and I rely on a lot of kind of other smart people who've written stuff about this. But there are two aspects to kind of where they should sit. One is from the perspective of kind of like what is the management and reporting structure, right? So who do they report into? How is their sort of career and growth evaluated? So that's one direction. And the other direction is, what are the kinds of projects that they do and how fast are they able to kind of work on them and deliver business value? And that's the second. In terms of the first, generally, like it seems that like data people like to be managed by sort of other data people, or at least people who understand sort of what data can do, what data can't do, right? And some of the challenges with data. So if you ask sort of somebody maybe who's like a business leader, or maybe who is like even an engineering leader, doesn't really work with data, to manage data people, like that can often be a little tricky, right? Because the just challenges are kind of unique. But when it comes to the actual projects that they do, right, it can be super valuable to have the data person embedded, right? I think Alexi, you were mentioning this for OLX, right? Because they are then able to, they have very close access to what that team needs, what are the business metrics that team is tracking, what actually works, what doesn't work. And so their cycles are much faster. They're able to make progress much faster. Some of the challenges that they run into then is if you're too independent, then there's sort of learnings across different data people percolating to everybody else. That can often take a bit of a hit. But then again, if there is sort of a common sort of reporting structure, hopefully like the manager who is directly managing like these 5 or 6 data analysts or data scientists, they should be able to kind of take the common learnings and sort of help the broader team. But yeah, I mean, I would say it's kind of reasonably sort of team dependent, but as long as there are ways for sort of common learnings to be shared and be adopted by the rest of the team, and there are, they can be embedded where they're learning from the business domain very fast, that's probably the best outcome. And this probably stops being true once the team reaches like a very large scale, because then there's probably too many data scientists to have like centralized reporting. But at least until like organizations are like 1,000 or so people, they should work.
Yeah. It's interesting that you mentioned that the data people like to report to data people, because what I saw when data science just appeared, that it wasn't clear what part of hierarchy, what part of structure data team belongs to. Like, should they report to product director, or I don't know, VP of product? Should they report to engineering director? Should they be engineering part of the engineering organization? And it's still like, well, not clear. Like data science, for example, like maybe it's closer to engineering, but then analytics is closer to product. Like it's not clear where to put them. So right now, for example, at OLX, we have chief data officer, and then we have the entire like sort of pillar.
Right.
I don't know if I can say that. So basically like entire hierarchy coming from the chief data officer down to data analysts and data scientists. And I see more and more companies are doing that, realizing that this is an important thing to do.
Yeah.
And then coming to this, should they sit independently or together? What I also noticed is sometimes like a bit of both works, because if analysts are constantly getting distracted by ad hoc queries, which often happens, right? So let's say they are sitting in a team, so they are working on some product things like understanding the impact of something, and then somebody comes and says, hey, I need this report for a board meeting tomorrow, right? So okay, what do I do here? So so what I see sometimes there is a team who is taking care of these ad hoc requests. Like perhaps like larger organizations can afford that, right? So they can afford a independent team for doing these kind of things. And at OLX, we had actually a BI department that was taking care of these ad hoc requests and also building some sort of infrastructure to enable self-service for business people. So that's
that sounds reasonable as well. If there's kind of common kind of infrastructure work that is being done by a separate team. And I mean, I'm guessing like the analysts must be happy that some of the ad hoc requests can be sent over somebody else.
Only some, unfortunately. So not all. So the embedded mode, I think, works really well. Still, analysts sometimes get too many ad hoc requests.
I mean, the reporting into data like when I say data people, it doesn't have that much to do with the title. It's about like, does the person kind of understand some of the natural challenges with data, right? Like I'll give you like a fictional example, I guess, right? So sometimes like data has like all sorts of weird problems, right? And a good kind of analyst or scientist like would basically look at that and say there's something really fishy here, right? And I better kind of investigate, right? And the ideal thing to happen would be like if they're being kind of very paranoid and diligent about, and which you should be like, about the quality of data, like they should be able to spend, hours to maybe a few days just investigating like where is this kind of record coming from, right? And now if you go to somebody who hasn't kind of faced these things before, they'll be like, well, just ignore it, it doesn't matter, right? But like that can have all sorts of negative consequences down the line. And almost like what you need there is kind of like support, right? It's like, yeah, like this is probably important. And then for the data person to just like go into detail and explain like, okay, here are all of the problems that can happen downstream, like that's not ideal, right? So at
Yeah.
least that's kind of my thought process on reporting.
So last week we talked about, so we had a guest and we were talking about building data teams. And so Tammy Liang was there talking about her experience. And then she suggested if she would start again building a data team, so she would start with hiring a data engineer, then hiring a business analyst and data analyst, preferably senior data analyst, and only then hire a data scientist after these 2-3 people. Right? Would you say you would do it the same way? Like, would you hire an engineer and then analyst and then data scientist, or you would change something in this approach?
Seems pretty reasonable, and I'm sure Tammy has like a lot of good experience to kind of back it up. I mean, I think data engineer, somebody who can just get stuff into a good place, that is like pretty critical, right? No, not much work can happen without that. And I think for most companies, this strategy seems reasonable. There are probably some companies that are very kind of machine learning focused, right? So their entire product might just be kind of like a machine learning thing, right? And this could be everything from like self-driving, sort of in like the very extreme case, to even kind of smaller models that are in fintech or healthcare. And so there, when the core business is kind of machine learning, right, then sort of the team structure ends up developing very differently. And it's like, often it's like it might be like a set of PhD students, right, or like not students but like folks with PhDs who get started, and then you add sort of engineers once you have to take certain prototypes and sort of productionize them. But for most teams, I think that advice from Tammy seems pretty reasonable.
Mm-hmm. Yeah, because like we talked about that companies tend to over invest into data science and under invest in data analytics, but yeah, maybe when they hire a person who knows in which order people should be hired, maybe that would change things. So maybe if we still see that there's overinvestment in data science, maybe we just, so these organizations are not mature yet. So maybe they need to hire somebody like some chief data officer or chief of data kind of person who would then structure hiring, right? So this is the order in which we should hire people. So first we need to have data engineers, to have infrastructure, then data analysts already to make use of data, and then only then data scientists. Right.
That sounds pretty nice, and hopefully more and more organizations move in that direction.
Yeah. So before we finish, I wanted to ask you about your newsletter. So maybe can you tell us a few words about this? So what are you writing about?
Absolutely. Yeah. So so a friend of mine and I, we had been for maybe years, like we'd been kind of trading notes and trading stuff about things that we're seeing in the world of machine learning, and especially, not so much research, but much more, how do you take machine learning and make it work in production? And then sometime last year, we just decided that, maybe we should just take some of the stuff that we're discussing and then put it into a newsletter and at least share it with some of our friends, right? And so that's how we kind of got started. And even kind of today, like we just think about what are the common challenges that teams are facing in production with machine learning, right? So all sorts of stuff around some system stuff, some machine learning stuff, and then just how do you make these systems kind of work? So that's something that we've been focused on. I mean, the sort of overall ecosystem is like folks kind of call it sort of MLOps. So our newsletter is called the MLOpsRoundup. It's on Substack. Yeah, please do check it out and let us know if you have any thoughts or feedback.
Yeah, I just realized that I mispronounced it at the beginning. I kept reading it MLOps rounds, and you didn't correct me. So
it's all good. I think I should have. I didn't kind of write out the name explicitly, and I should have.
Yeah, but the link is correct. So because I copy
Yeah.
pasted it, so the link is fine. So if you
Yeah.
I'll put the link in the description, of course. Thanks. How can people find you?
So yeah, please, you can find me on Twitter. So my Twitter handle is it's Rish_Bhargava, which is RISH underscore my last name. And then otherwise, feel free to, if you're, I'm in the Data Talks Slack channel, so feel free to find me and send me a message. Always happy to chat.
Okay, thanks a lot. Thanks for this fruitful discussion. It was a pleasure to talk to you. Thanks everyone for joining us today and for asking questions. And yeah, thanks.
Thank you so much, Alexei. Yeah.
Yeah, have a great day. It's nice talking to you.
Thanks a lot. Yeah.
Goodbye.